Hello students, welcome back to Akshar IIT online classes. I am your chemistry faculty S. Mohan. Students, in the previous class, we were discussing about the valency. Did you remember what is valency? Yes, the combining capacity of an atom is called valency. The combining capacity of an atom is called valency. What is the combining capacity? Different elements have the different capacity to combine with the different elements. So that is called valency. This already we discussed. Like for example, if you see oxygen has a capacity to combine with the two hydrogen atoms to form water molecule, right? H2O. Here oxygen is combining with the two hydrogens. So valency is what? 2, right? Similarly, here other elements. So hydrogen has a capacity, means hydrogen valency is only 1 because two hydrogens are combined to combine with the oxygen, right? So different elements have the different capacities to combine with other elements. This is called valency, and we discussed in the previous classes about the valencies. Okay, so today in today's class we are going to discuss about variable valencies. What it is? Variable valency. What is meant by the variable valency? In the last class we discussed that hydrogen, for example, hydrogen exhibit the valency of +1, chlorine exhibit the valency of -1, oxygen exhibit the valency of -2, potassium exhibit the valency of +1. Yes, we discussed these things in the previous class, and based on this we solved the exercise also. So today, variable valency. Variable valencies. Variable. So hope you know what is meant the variable. Yes, variable means what? Which vary. Vary means what? Which changes. So here one element has two or more different valences, then we can call it as a variable valency, right? If one variable has, if one element has only one valency, okay, but few elements in the periodic table, they exhibit different valences. So for example, copper. See students, here copper exhibited two types of valencies. Copper with valency 1, copper with valency 2. Copper can exhibit two types of valencies, +1 and +2. So here whenever the copper exhibit +1 valency, then we indicate with the Roman number 1, and if the copper exhibit +2 valency, we indicate with the Roman number 2. So here only copper, but it has different capacities to combine with the different elements. So it can exhibit +1 valency and it can exhibit a +2 valency, right? Similarly, so many elements are there. Like for example, if you take the iron, okay, ferrum, right? So here this also exhibit +2 valency, +2. Ferrum also exhibit +3 valency, but we can say, I'll say the different names are there. So it exhibit the +2 valency, we write the Roman number 2, and here we write the Roman number 3, like this. So here different element means few elements exhibit two or more than two different valencies. Okay, so such valencies are called variable valency. Such valencies are called what? Variable valencies. Okay, so now once if you open your material, Page number 27. Page number 27. So see a concept of variable valencies. When an element exhibits more than one valency, it is said to be exhibit a variable valency. If one element exhibiting two or more than two valencies, then they will call them it as a variable valency. Now, for example, there is one table is there, students. Once you see here, in this table, ferrum. So just now I told you that ferrum. Ferrum can exhibit a +2 valency and a +3 valency. Ferrum can exhibit means iron can exhibit a +2 valency and a +3 valency. For example, ferrum is exhibiting +2 valency. Okay. For example, let's take one compound like okay, FeCl2. FeCl2 is a compound in which ferrum means iron exhibiting 2 valency. And here FeCl3. Here iron, that is ferrum, exhibiting 3 valency. How? In the previous class I explained you like crisscross method. Did you remember the crisscross method? For example, I explained like water. Water formula is H2O. So hydrogen and oxygen. Hydrogen valency +1. Oxygen valency -2. Okay. So now what we do? Here we need not to write the charges. So we write hydrogen valency 1, oxygen valency 2. Then what I said, to crisscross them. So when we crisscross, what happens? This 2 comes to the hydrogen and the valency of oxygen the valency of hydrogen come to the oxygen. So if it is 1, we need not to write that 1. So it becomes H2O. This I explained in the last class, right? So valencies get crisscross. So if we have the compound like water, in this water it indicates that the formula is H2O. Here it indicates that the 2 is the valency of oxygen. 2 is the valency of what? Oxygen. Here no number is there. So this is 1 is the valency of hydrogen. Crisscross method. After crisscrossing, we'll get this formula. Okay. So before crisscrossing, what happens? This 2 belongs to oxygen. So this 2 is a valency of oxygen, right? And here 1 is belongs to the hydrogen. So similarly, here see, actually this is a compound. This is a compound, right? So here a compound is formed when after exchanging the valencies. After exchanging the valencies. So before exchanging, what happens? This 2 goes to the iron. Yes or no? So Fe, this goes to here. Okay. And the chlorine, here no number is there. This 1 is going to here. So now these are the actual valencies, +1 and -2. So here in this compound, iron valency is 2. So that it is crisscrossing. So that 2 is going to the chlorine. So here +2 is the valency of iron. Yes or no? In the previous class we discussed. Very good. Now here what happened? What is the valency of iron? This after forming the compound. Okay. So now here before formation of compound, what we write here? We write iron. We write here chlorine. So here actual valency of the iron is 3, that is +3, and chlorine is -1. Right? So this is getting crisscrossed. After crisscrossing, we get this FeCl3. No. So here, so this 3 is the valency of iron. So here in this compound, iron is exhibiting the +3 valency. In this compound, iron is exhibiting the +2 valency. Is this clear? So iron exhibiting 2 types of valencies. So due to that, with the same element, it is forming 2 different compounds. FeCl2, FeCl3. Clear to you? Right? Sure. Now, what is the name can we give to this one? Okay, Fe means what? Iron. So can I call it as an iron chloride? Can we call it as an iron chloride? Both are iron chloride, only this is iron with chlorine, this is also iron with chlorine. So can I call this as an iron chloride or iron chloride? Is yes. But here, how can we come to then what is the difference between these two here? 2 chlorines are there here, 3 chlorines are there. So that's what some new name should be given to it. Okay. So what the name should be given to them? Now see here. Now when FeCl2 is there, where Fe is exhibiting +2 valency. So then the name of this one is called ferrous. Okay, ferrous chloride. What is the name of this one? Ferrous chloride. Now here, what the name we can give to this one? Ferric chloride. Did you observe the difference here? What is the difference here? This is ferrous. This is ferric. Since FERR is common. Difference is what? OUS. Here difference is what? IC. So OUS is called what? US. Here IC is called what? IC. Is this clear to you? So here iron exhibiting two types of valencies. One is +2, one is +3. Okay. So +2 is lower valency. When it is lower valency is there, we can give that us. What we can give? Add the suffix us. Ferrous. Okay, chloride. If it is a higher valency, ferric chloride. Is this clear to you? For lower valency, ferrous, us we add, OUS. For ferric chloride, for higher valency, ic, we add ic. If one element only exhibiting two types of valences, in that we see which is a lower valency, which is a higher valency. If it is a lower valency, we can call it as a us. Okay. If it is a higher valency, we can call it as a ic. Clear to you? Chalo. Now, if you understood or not, let me check now. Let me check, students, now. So here copper, this copper exhibiting the valency of +1, here copper is exhibiting the valency of +2. Clear? Now what I do? Here I write CuCl. Copper valency is what? Copper symbol is what? Cu. And I am writing chlorine. Here I am writing CuCl2 because its valency is 2. You know that how to write the formulas. So here copper valency, it is exhibiting the +1. So means 1. And chlorine, you know that chlorine valency is 1. They both are crisscrossing CuCl. 1 if it is there, we need not to change. Now similarly you can do Cu, its valency 2 if it is exhibiting +2. And chlorine, you know that valency is 1. They are crisscrossing, this one is going here, so we need not to write Cu only, and this Cl2 is coming here, so this is CuCl2. So here copper is combining with the chlorine in two ways. Okay, one is it is forming, it's combining with one chlorine called CuCl. It's combining with the two chlorines here, it is CuCl2. Now, what is the name of this one? What is the name of this one? So here you see, here it's exhibiting two valencies. Here the valency of copper is +1. Here the valency is +2. So +1 is called lower valency. +2 is called higher valency. Clear? Now once it goes here, this is called lower valency here. This is called higher valency. If it is lower valency or if it is higher valency, what the name should be given here? I written with the ferrous. Okay. Now what is the name for this one? So a copper, Latin name is what? Cuprous. What is the Latin name of copper? Cuprous. Okay, cuprum actually. Cuprum. Chalo. Now you say the name of these two. Come on, fast. What is the name of this one? Say loudly. Little louder. Very good. So now, here the name of the first one is what? Good. So that is called the cuprous chloride. Cuprous chloride. What is the second one name? Good. That is cupric chloride. Cupric chloride. So here why you are calling as a cuprous and why you are calling as a cupric? Because here the copper is exhibiting the +1 valency. For lower valency, the suffix will come us, OUS. And for it is a higher valency, it comes ic, cupric. Clear to you? So, if any element exhibit two valencies. In that, if for a lower valency, we should add the suffix as us. Okay, and if it is higher valency, we should add the suffix ik. Clear to you? Chalo. Now, once you open the material, that's page number 27. So you can see there table. In that table, you see now iron. Okay, chemical name is what? Ferrum. And name of the lower valency, ferrous. Lower valency, ferrous, us is coming. And name of the higher valency, ferric, ik is coming. Right? Now, copper, Latin name, cuprum. And lower valency, cuprous. Higher valency, cupric. Similarly, silver. What is the Latin name of silver? Argentum. Argentum, already we discussed. If it's lower valency, argentus. Higher valency, argentic. Clear? Next, mercury. Mercury also exhibit two valencies, 1 and 2. So, lower valency, mercurous, and higher valency, mercuric. Clear? Okay. So, here see students here, once again I am telling, here you see here, FeCl2 is there, we are calling ferrous chloride, right? And here CuCl2 is there, Cl2Cl2, cupric chloride. You don't call this as, okay, cuprous chloride. Why? Because copper exhibit only 1 and 2 valencies. In that, one is the lower valency. Okay. So, for lower valency, you have to say cuprous. So, you don't say that, sir, here FeCl2 is there, CuCl2 is there, when 2 is there, I am calling a ferrous chloride. Why I don't call here this as a cupric chloride, cuprous chloride. Okay. So, here you have to check only that particular element. So, copper only you have to say copper exhibit two types of valencies, +1 and +2. For lower valency, us, higher valency, ik. So, 1 becomes us, 2 becomes ik. Similarly, but when you come to the iron, it exhibits +2 and +3 now. Yeah, +2 becomes lower valency, +3 becomes higher valency. So, +2 is called as us and +3 is called ik. Right? Chalo students, this is one thing. Now, here, see here I am calling this as a ferrous chloride, ferric chloride and so on. Right? Sometimes we can also write this ferrous chloride. Sometimes ferrous chloride also can be written as iron chloride, because Fe is what? Iron. So, Fe means what? Iron. So, iron chloride. You can write iron chloride. But if you write iron chloride, then you have to mention that what is its valency? 2. So, between the iron and chlorine, or beside the iron, you should mention +2. Like this also you can write. Okay. So, if it is ferric chloride you are writing, you can call it as a iron chloride. Okay. But what's exhibiting its +3 valency? So, write in the, okay, beside the iron, Roman number 3. So, we can, the person who is studying, so who is reading, they can come to know that, he can understand here iron is exhibiting the valency of +2, here iron is exhibiting the valency of +3. Clear? Okay. So, better writing, this is a better way actually, but in some cases you can write like this also, or you can, some cases you can see in a materials also or textbook also somewhere, you can see like this also, iron chloride, in the bracket they will write +2, I mean Roman number 2. The meaning is what? There, in that iron is exhibiting +2 valency. Clear? Okay. So, hope it's very clear to you, because it's a very, very important. Since we can have, see, we have so many compounds, millions of compounds are there in the chemistry, millions of compounds, not 1 or 2. Okay. So, we cannot, buttify, okay, all these compounds. You should know the way of giving the names to that compounds. Okay. So, that's called like nomenclature, giving the names to the compounds, nomenclature. Okay. So, there are certain rules out there. If we know these rules, then you can write any formula, and if any formula is given, you can name that compound. If a compound name is given to you, you can write that formula. Okay. So, try to understand, that's a very, very important concept. Okay. Chalo. Hope you understood this one now. Now then come to the types of ions. Okay, now let's come to the ions. Shall I rub this one now? I'll rub it. So students, now I'm going to explain the very important concept. Okay, very carefully, very concentratedly. Okay, now listen this concept. Okay, 1 minute. Okay, so students, now very important topic, very important topic. So try to understand and completely concentrate here. You know that element, and the smallest unit of element is atom, right? So already we discussed what is the atom, right? So I'm writing atom, right? This atom actually it's a very smallest particle. I said that any matter is made up of miscomposed or made up of a tiny particles called atoms. Tiny particles means what? Very small particles called atoms, right? Now these small particles also still they consist of more smaller particles. Atoms we can't see. Even with normal microscope also we cannot see the atoms, such as smaller particles or atoms. But still, okay, in that atom some other particles also present, okay, which are called subatomic particles, right? In that term, some 3 important particles are there, which are called fundamental particles. What are they? Fundamental particles. These fundamental particles, 3 are there. How many? 3 types of particles are there. One are called electrons. Did you listen the word any time? Electrons. Yes, they are only electrons. So electrons. And next word did you listen along with electrons? You listened electrons means you listen some other words also. What is that? Protons. Very good. So protons, electrons, protons, and neutrons. So these 3 are the important particles that present inside the atom, right? Now, so inside the atom there are 3 different particles are there. First one are called electrons. Okay. Second one are called protons. And third one are called neutrons. Okay. Electrons, repeat with me. Atom consists of 3 fundamental particles. What are they? Electrons. Repeat loudly. Electrons. Good. Protons. Neutrons. So these are the 3 particles are there. Right. And in these particles, electrons possess the negative charge. Negative means what? Minus. Negative means what? Minus. Electron possess negative charge means what? Minus charge. Proton carries positive charge. Protons has which charge? Plus. Positive is what? Plus. Neutrons have no charge. They don't have any charge. Right? No charge. 0. So now charged particles, what are the charged particles here? 2 particles. One are electrons, second are called protons. Electron carries the negative charge, protons carries the positive charge. Right? Now, generally you take atoms, generally atoms are neutral. Neutral means what? No charge. Neutral means what? No charge. Okay, even though atom has electrons, protons, neutrons, but atom is neutral. Atom has negatively charged particles are there, positively charged particles are there, and neutral particles are there, but still atom is neutral. Can you say why? Because the number of electrons is equal to number of protons in an atom, right? Means what? For example, hydrogen is there. Let imagine, hydrogen is there. hydrogen has one proton, one electron. One proton, one electron. So proton carries which charge? Plus charge. So I am writing plus 1. Electron carries which charge? Minus 1. So I am writing minus 1. Now plus 1 means what? We need not write the plus, you know that. Okay. So 1 minus 1. Plus 1 means 1. 1 minus 1. What is the answer? 1 minus 1? 0. Right? So the atom is neutral. Atom is neutral. Neutral means what? No charge. 0. Even though that has a positive charge particles, plus charge is there, minus charge is there, but still their charge is 0. Okay? Why? Because number of electrons is equal to number of protons. Now, for example, if you take the helium. Take the helium. Okay, helium. So, see students now. Hydrogen, helium. I'll take 2, 3, not more than lithium, beryllium. Okay, I'll take 4. Right, 4. Now, in the helium, here I am writing number of protons. Number of protons. Here I will write number of electrons. And charge, net charge I am writing. Net charge. What is the charge on hydrogen? Right? So now hydrogen has one proton, so plus 1. Hydrogen has one electron, minus 1. Plus 1 minus 1 is what? 0. Correct only now? Helium has 2 protons, means what? Plus 2. Helium has 2 electrons, means what? Minus 2. Plus 2 minus 2 is 0. Correct only? Now lithium has 3 protons, means plus 3. Lithium has 3 electrons, so minus 3. Plus 3 minus 3, 0. Similarly, beryllium has 4 protons, means plus 4, and the number of electrons also 4, so minus 4 is equal to 0. So meaning is what? You take any atom. You take any atom, that atom consists of how many protons present inside the nucleus, the same number of electrons will be present. Means the number of electrons and protons are same. Is this clear? The number of electrons and number of protons are same. The net charge is 0. The net charge is what? 0. Clear to you? Understood? Okay. For example, your father is given 1 rupee to you, and your sister is taken 1 rupee from you. Then what is the charge? What is the net amount present with you? 0. Your father is giving 1 rupee, so plus 1. For example, your sister is taking that 1 rupee, so minus 1. Plus 1 minus 1 is what? 0. Clear? So any atom is a neutral. Clear? Right. Now, chalo. I am rubbing this one. This you understood now? Chalo. I am rubbing this one. It's not coming, going late. Chalo. This you understood now? I am rubbing this one now. This also I am rubbing. Okay. So now, the neutral means what? No charge. So neutral, generally atoms are neutral, right? But here these atoms, if they possess any charge, then they are called ions. What they are called? Ions. So means what? Atom with charge. Atom with charge is called ion. Atom with charge is called ion. Right? So, but which charge here? Charges are 2 types. Just now I told you. Charges of 2 types. Plus and minus. Okay? So, 2 types of charges are there. Plus and minus. So, if atom consists of, okay, positive charge, then that is called cation. What it is called? Cation. Okay. And ion means atom which consists of negative charge is called anion. What it's called? Anion. Okay. So, how this cation is formed? When atom losses. Okay. Losses. Okay. Losses electrons. Electrons. Then cation is formed. Okay. Here, when atom gains, means takes electron, then it becomes a anion. What it is called? Anion. Is this clear to you? If atom loses, for example, I am taking one atom M. If it is losing one electron, then it becomes M plus. If atom is losing two electrons, it becomes M plus 2. If atom is losing 3 electrons, it becomes M plus 3, like this. How many atoms, how many electrons it loses, that much amount of positive charge it will get. Now here atom, for example taking X, if gaining 1 electron, it becomes X minus. If it is taking 2 electrons, it becomes X minus 2. If it is taking 3 electrons, it becomes X minus 3. Okay, and if it is these which are acquiring the positive charge, these are called electropositive ions. Electropositive ions, because they have the positive charge. And these are called electronegative ions. Electronegative ions. So here if only one charge is there, they are called monovalent. What they are called? Mono. If they contains 2 plus charge, they are called divalent. If they possess 3 plus, they are called trivalent, and so on. So students, now if you open the page number 28, today's your work. Today's your work is, open the page number 28. So here you can see monovalent, divalent, trivalent, tetravalent. Okay, ions are there. So these all ions you have to learn. Okay, so first here copper plus 1, so cuprous, silver Ag plus, argentus, gold Au plus, Aurus, mercury plus 1, mercurus, ammonia NH3, ammonium, phosphonium. These all are monovalent with positive charge plus 1 unit of positive charge. Next, divalent means what? 2. Copper plus with 2 positive charge, that's called cupric. Just how I told you before that. And mercury, so plus 2 is called mercuric. Okay. Next, iron with the plus 2 is called ferrous. Chromium, chromus. Okay, like this. So this all, today's your work is to learn, okay, this monovalent, divalent, trivalent, tetravalent elements you have to learn. Okay. So in the next class we are going to discuss about the practice sheet. Practice sheet 4. So to do this practice sheet 4, you have to learn all this and should be able to do this practice sheet without turning off the papers. Without turning off papers, you have to do this exercise. So today's your work is what? To learn all this monovalent, divalent, trivalent and tetravalent positively charged, only electropositive elements are there. In the next synopsis, we have the electronegative. Similarly, like how we discuss electropositive, similarly electronegative. So even you can read the 2 also, even synopsis 5 also, all about the electronegative. Okay, this is similar to electropositive only, right? So synopsis 5 is also electronegative, same. I need not to explain about that. If it is gaining 1 electron, that's called monovalent but electronegative. And if it is gaining 2 electrons, divalent. And if it is gaining 3 electrons, trivalent. Okay. So same, this also similar to that one. So you can complete synopsis 4, synopsis 5. Both the compound names and their valences you have to learn. So we directly solve the practice sheet, exercise 4 and 5 in the next class. Okay, so go through this, both the synopsis 4 and synopsis 5. Clear? Any doubts? Students, if you have any doubt, you post in the chat box. Okay. So, because I hope you are very intelligent, because you are not posting not even a single doubt to me. Right. So, very good. I appreciate you. Okay. So, with this, we'll stop, students. So, today's what's our homework to you? The homework is to complete the synopsis 4, synopsis 5, and the synopsis 4. Electropositive elements are there with the different valences, variable valences, and synopsis 5, electronegative elements are there with the same different variable valences like -1, -2, -3, -4, and so on. Okay. So take care. Bye. With this, we stop our class.